Hi students, very good morning to all. Students, in last class, we started second portion of thermodynamics, and that is thermochemistry. In this chapter, we'll study heat energy changes present in a chemical reactions. We always express the change in heat energy, or we measure change in heat energy in a chemical reaction with help of two terms. One is delta H and another one is delta U. Delta H is heat of reaction at constant pressure. Delta U is heat of reaction at constant volume. The relation between delta H and delta U is delta H equal to delta U plus P delta V. For solids and liquid reactions, I mean, in a chemical reaction, only solids and only liquids are present. Then P delta V is considered as a zero because there is no change in volume of the system. In that case, delta H equal to delta U. No difference between heat of reaction at constant pressure and constant volume. For gases reactions, definitely you must consider P delta V as delta nRT, where delta N is number of moles of gaseous products minus number of moles of gaseous reactants. Students, have you done that question? Completed? Combustion of acetylene. Have you done that question? Okay, right. So, what is the correct answer? Acetylene combustion. Acetylene formula C2H2. With oxygen, we will get carbon dioxide and water. Balance this equation. X plus y by 4. 2 plus 2 by 4. 2 plus 1 by 2. It is 5 by 2. X CO2. 2 CO2. Y by 2 H2O. 1 H2O. We know that already balancing chemical equation, particularly combustions of hydrocarbons. Acetylene is a gas, oxygen is a gas, carbon dioxide is a gas, but students here, water is a liquid here. The, the water is liquid state. Now delta N value is 2 minus 1 minus 5 by 2. What is the value? 2, 4 minus 1. So minus 3 by 2. Am I correct? Delta H equal to delta U plus delta nRT. Delta H minus delta U, delta N value minus 3 by 2, R value in kilocalories 2 into 10 to the power of minus 3, temperature 300. If you solve this, you will get 0.9 kilocalories per mole. Understood? 0.9 kilocalories per mole. Understood? R value in calories, 2 calories, kilocalories, 2 into 10 for minus 3. In joules, 8.314, kilojoules, 8.314 in 10 for minus 3. Students understood? They said combustion of acetylene, Abhinash. What is combustion of acetylene? Reaction with oxygen. In combustion of hydrocarbon, the products are carbon dioxide and water. Water must be in liquid state always. Don't take in gaseous state. Carbon dioxide must be in gaseous state. And balancing this equation, I have given already one general formula. CXHY equal to X plus Y by 4, O2 gives rise to XCO2 plus Y by 2 H2O. Okay, right. So next concept is heat of reaction. Heat of reaction. What is heat of reaction? Reactants converted into products. I have given many times none of these examples. Still many are asking again. Okay, right. Students, reactants converted into products. In, in a chemical change, we can expect maybe heat is released, that is exothermic reaction. Sometimes heat is absorbed. How much heat is released or absorbed when reactants completely converted into products? That heat energy is called heat of reaction. Okay, so definition is at a particular temperature, at a particular temperature, the amount of heat energy is released or absorbed when a chemical reaction is taking place according to according to stoichiometric equation, and all reactants completely converted to products is called heat of reaction. So delta H or delta U, we measure heat of reaction. Both are heat content of products minus heat content of reactants. Sum of, if this value is positive, it is endothermic. If this value is negative, exothermic. Students completed. Okay. Factors affecting heat of reaction. Factors affecting heat of reaction. The first factor, students, the physical state of reactants and products. Example, hydrogen gas plus oxygen gas, both are react together, we will get water. In second equation, same, H2 gas plus O2 gas will get water. In first case, if the obtained water in gaseous form, second state in liquid form, the physical state of product is different. Then delta H in this case is minus 57.8 kilocalorie per mole. In this case, delta H is minus 68.32 kilocalories. You can observe the difference in heat of reaction. So the physical state of reactants and the products, if changes in a same chemical equation, then heat of reaction also changes. Yes, definitely students, this value is low, this value very high. Reason, the formed liquid, if it is converted into water, gas, it is endothermic process. So some amount of energy here again utilized to bring this water into gaseous form. So whatever it may be, physical state changes, heat of reaction also definitely changes. That is the point. Understood? Completed. Okay. So next, second factor is allotropic forms of an element. Carbon in diamond form, it is one allotropic form of carbon, react with oxygen, will get carbon dioxide. Same carbon in graphite form, it is another allotropic form of carbon, react with oxygen, will get carbon dioxide. The reaction is same, the products also same. The carbon we are taking in different allotropic forms. Delta H in this reaction is minus 94.3 kilocalories. In this reaction, minus 97.6 kilocalories. Students, if you change allotropic form of any element, definitely heat of reaction also changes. Okay, are you getting? So we should consider allotropic forms also. My question is, with help of these two equations, can you give carbon diamond converted into carbon graphite? What is delta H? Abhinash, very good. Yes, completed students. And how can we calculate carbon diamond converted into carbon graphite? Very easy. We need in reactant side diamond, product side graphite. Okay, just reverse this equation. Second is just reverse this equation. Then if you reverse this equation, carbon dioxide here in product side, reactant side oxygen, carbon, graphite. If you reverse the equation, this value also will be reversed. Add both the equations. Carbon dioxide cancel, oxygen cancel. Remaining carbon diamond, carbon graphite. So plus 97.6 minus 94.3, answer 3.3 kilocalories. Understood? This is called heat of transition. One allotropic form converted into another allotropic form, and that kind of process is called transition. Okay, the amount of heat released or absorbed during that process is called heat of transition. At which temperature diamond converted into graphite, that is called transition temperature. Completed students? Okay. So this is about second influencing factor on heat of reaction. And the third influencing factor is pressure. Yes, we already studied at constant pressure, delta P equal to 0. If you perform a chemical reaction at constant pressure, then heat of reaction, we should get always in delta H form. Delta H form. Enthalpy of reaction, that is called enthalpy of reaction. And fourth factor, volume. If volume is keep constant during process, then delta V equal to 0. At constant volume, the measured heat of reaction is called delta U. Is delta U. Simply just write volume is constant, pressure is constant. Students, completed pressure effect and volume effect. Next, very important factor and last affecting factor is temperature. If you perform a chemical reaction, reactants converted into products at temperature T1, definitely you will get delta H1. Same reaction if you perform temperature 2 to T2, then there will be new heat of reaction. Definitely that is new, that is delta H2. So temperature changes, heat of reaction also changes. Why? At different temperatures, heat capacity of reactants and products also different. So that's why students, there is a significant effect of temperature on chemical equations. And how can we study temperature effect? With help of Kirchhoff equations. The change in heat of reaction by temperature can be studied by Kirchhoff equations and very important equations. Okay, let us consider a chemical reaction A to B changes at temperature T1. The observed heat energy is delta H1. If you change temperature T2, what is delta H2? How can we calculate delta H2 value? At constant pressure, if you do delta H, we know that it is heat content of products minus heat content of reactants. Heat content of products minus heat content of reactants. Just differentiate this equation with help of temperature with respect to temperature at constant pressure. D delta H by dt at constant pressure equal to d delta products by dt differentiation of HR with dt at constant pressure. Students, we know that dH by dt at constant pressure is called molar heat capacity at constant volume, at constant pressure. So that is Cp of products minus reactants. We know Cp and Cv. Cp products minus Cp reactants is delta Cp. Delta Cp equal to d delta H by dt at constant pressure. Now we can write this equation as d delta H equal to delta Cp into dt. Students, listen carefully. dH by dt at constant called Cp, molar heat capacity at constant pressure. Cp products minus Cp reactants is delta Cp, change in molar heat capacity at constant pressure. Then d delta H equal to delta Cp dt. Just integrate this equation from delta H1 to delta H2, T1 to T2 temperature, where delta Cp is constant for a chemical reaction. Then it is delta H2 minus delta H1 equal to delta Cp into T2 minus T1. Now new delta H2 equal to delta H1 plus delta Cp into T2 minus T1. Students, with help of this equation, we can find Students, completed. So do you understand how can we find new heat of reaction? Yes, this equation is very important equation, students. Temperature effect. Again, same equation you can get if you take delta U equal to internal energy of products minus internal energy of reactants. Similarly, if you solve this at constant volume, you will get delta CV equal to delta U2 minus delta U1 by T2 minus T1. So we can measure heat of reaction at constant volume with help of this internal energy. Again, this delta CV, delta CP or delta CV. So please remember this sum of molar heat capacities of molar heat capacities of products minus sum of molar heat capacities of reactants. Students, in question they will mention delta CP directly, or sometimes we need to find. So don't confuse. So it is a second Kirchhoff law. Kirchhoff equation. Okay, completed. So next, students, various types of heat of reactions. Various types of heat of reactions. The first one is heat of formation. It is called delta HF. Students, generally, most of the chemical reactions at constant pressure. So that's why mostly we represent with delta H. Okay, don't confuse. Heat of reaction or enthalpy of reaction, both are same. Mostly at constant pressure, that's why delta HF. Okay. Heat of formation means at a particular temperature, the amount of heat energy is released or absorbed when 1 mole of a chemical compound is obtained. 1 mole of a chemical compound is obtained from its from its constitute elements. Example, if you want to prepare carbon dioxide, you can prepare by number of methods: combustion of carbon, combustion of methane, combustion of acetylene. There are many sources. But the point here, heat of formation, you should prepare 1 mole. And even that from elements, constituent elements. Example, carbon dioxide should be from carbon plus oxygen gives rise to carbon dioxide. Yes, it is called completely heat of formation of carbon dioxide. Or if I want to prepare CH3COOH acetic acid, its constituent elements are what? Carbon plus hydrogen plus oxygen gives rise to CH3COOH. So it is the meaning of a chemical compound is obtained from its constituent elements. Understood? Is called heat of formation. Students, are you getting or not? So అలా అయితేనే heat of formation. Acetic acid can be prepared by different sources, but it is the method, it is the reaction. From it, if you get acetic acid, that is called heat of formation. Delta Cp, delta Cv means Cp of products minus Cp of reactants. Cv of products minus Cv of reactants. Next exam syllabus, ionic equilibrium up to buffer solutions. Students completed? Okay. Next, students, standard heat of formation. Standard heat of formation, it is represented by delta HF naught. Delta HF naught. No thermodynamics for exam. No thermodynamics. Standard heat of formation. So same students, same definition at a particular temperature. At a particular temperature, the amount of heat energy released or absorbed when 1 mole of a chemical compound is obtained from obtained in its obtained in its standard state. So the meaning is different here, students. Chemical compound is obtained is called eta formation, but standard eta formation, chemical compound is obtained in its standard state and standard state from its constitute elements also in standard state is called standard heat of formation. What is standard state? The meaning of standard state, the most stable physical state of the most stable physical state of a substance at 298 Kelvin and 1 atmospheric pressure is called standard state. Students completed. Students, please practice questions from thermodynamics every day, at least 10 to 15 questions. So at least try to